Now we're going to talk about how we get smooth muscle contractions. And we do that through a process called summation. So if I make a little graph here, and I'm going to put on here the action potential and a muscle twitch, which is the result of the stimulus of the action potential. So on this side, we have our millivolts, so positive 30 is about what it comes up to, right? Starts at negative 70, that's resting. And then down here we've got time. Okay, so the action potential, of course, starts at the neuron. So we know this. So we get an action potential at the neuron, comes up to here, down here, and here's my action potential. So action potential at the neuron. Okay, that gets sent over to the muscle cell, and then we have action potential at the muscle cell, and that's what triggers the muscle contraction. So muscle cell. Okay, so this will can stimulate or start a muscle contraction, and we know that a muscle contraction is the result of the stimulus of the motor units within a muscle. So each motor unit that is stimulated then will contract and cause a muscle twitch. Okay, so if we look at that and we add this to our graph, so I'm going to put a little line here because this is the muscle contraction is not in millivolts, right? We're talking about tension. Okay, so the muscle cell then, we'll do that in pink, purple. So the muscle cell then will start, here's the muscle cell, and remember that the muscle cell is going to enter 3 different phases. So it'll enter a latent phase, and then it will contract, and then it will start to relax until it's back to resting. So this is a muscle twitch. The phases are this one here, from here to where it starts contracting, that is the latent phase. And what's happening during there? Well, a lot of things are happening. The action potential is getting there. We're getting the coupling of the electrical stimulus over to a mechanical thing. That's occurring there. And once that happens, then we get the phase of contraction. Right? And the phase of contraction lasts up to here, to about there. And then we enter the phase of relaxation. And that creates a muscle twitch. Okay, so how do we get this muscle twitch into a strong, smooth muscle contraction? Because one muscle twitch from one motor unit probably isn't going to get you to threshold, probably isn't going to get any movement. So what can we do to get strong, sustained muscle contraction we can stimulate the muscle multiple times. In effect, summing up those muscle twitches into a strong muscle contraction. Okay? So if we look at it on another graph here, the graph over here. So make another graph here. Okay. And again, we're talking about tension because we're talking about the muscle contraction now. So tension is on that side. Time is on this side. And if we have a muscle, that muscle is at rest, right? And then we stimulate it, and with an action potential, then that muscle starts to contract. It'll contract, it'll start to relax, and instead of letting it completely relax, we can stimulate it again before it relaxes. And when it does that, it's going to contract again, and the next contraction is going to be stronger. Okay? When that one starts to relax, we can stimulate it again. And again, it will start to contract, and it will contract more than the one before that. So they summate. We're summating. So summating the contractions. Okay? So we can continue to do that and we'll get here. And will it go forever? No, there's no way it's going to go forever. You're only as strong as you are. So there is a max here. But we can still continue to stimulate that muscle over and over before it completely relaxes. And as it's doing that, it's up here doing that. We call that ability, where it's just going and keeps contracting without being completely relaxed. We call that unfused tetanus. And if we keep stimulating it faster and faster, quicker and quicker, then eventually there's no relaxation. It eventually gets to a point where it doesn't relax at all. Okay, that is called fused tetanus. So fused tetanus is the absolute maximum strength of that one motor unit. Okay? Most of your actions, most of your muscle contractions occur in unfused tetanus. Fused tetanus is something that is the complete maximal of what that motor unit will do, and it isn't a sustainable type of contraction. It's going to fatigue. Okay? But summation, in summation, and we call this wave summation, we increase the power and increase the strength. So strength of contraction is increased by increasing the speed of stimulus. So we're summating the stimulus. We are stimulating it over and over and over, and we're doing it faster and faster and faster. And that is going to increase tension. Okay, here's tension going up. Okay, again, that process is called wave summation. And wave summation allows for smooth, powerful contractions. Powerful contractions. Okay, so if in this case with wave summation, we are looking at motor units. Okay, if we need for the muscle itself to generate more power, then what would we need to do? Well, probably we need to have more motor units employed so we can recruit more muscle units to add to the power of that contraction.